Welcome to Module 6, Lesson 1, Complementary and Supplementary Angles. Now, those are two terms, complementary and supplementary, that you most likely have come across. You may have forgotten what they actually refer to when we talk about angles, but that's okay. We're going to talk about that again. Actually in lessons 1 through 4, we will be practicing identifying angle relationships, okay, in problems, and then modeling the relationships with an equation. Okay, so we're going to go ahead and link another link back to equations, which we haven't seen in quite some time. And these equations, of course, will yield an unknown value. Okay, so we're going to actually solve for unknowns. There are going to be 4 of these unknown angle lessons, and hopefully by the end of those 4 you should be fluent in this topic and be able to solve for the missing angles in problems that incorporate multiple angle relationships, okay, and do so with mastery. Okay, you've been hopefully been solving problems like this. We actually did some time ago, and we talked about geometry before. In terms of angles on a line, you're going to see that again, as well as these two terms here, complementary and supplementary, in this lesson. Okay, so let's go ahead and get on with it. So firstly, let's go ahead and review some key definitions and angle facts, okay, or statements. All right. So let's go ahead and review some key definitions here in this first activity. So over here you can read the definition, all right, and then you're going to fill in that blank, and the term you're going to write over in this area right here. Okay, so I want to go ahead and give you a little time to do that. So if you'd pause, see if you can fill in those blanks, and then we'll go over those together. Okay, so if we look at this here, I'll read this first definition here with the blank. It says 2 angles, angle AOC and COB with a common side OC are blank angles if C is the interior of AOB. Okay, now we can go ahead and take a look at that. I'm not sure if you did get that actual definition there. I'm not quite sure, but there is a hint on the page. All right, so if we're looking at something, if we're looking at this like AOC, we can look at angle like that. We have like AOC, and then we have AOB. Okay, so AOC, and then we have AOB. Let's see, AOC, and then AOB, like that. Okay, so we have little arrows there. So if you have AOC, and then you have COB, okay, and we have the common side here, which is OC, all right, and this C is in the interior of AOB. So there's AOB, and you see C is in the interior. Well, anyway, cut to the chase there. These angles are called adjacent. Okay, so again, all of this here, this definition is just so darn convoluted sometimes. But I mean, I guess it is. You can understand it if you read it and draw it. I mean, I had to draw it out. But anyway, you can see that adjacent angles down here. If you look at that one, and you can see how that looks very much like the one I drew, my messy one. Anyway, let's go ahead and look at that second definition here. And it says when two lines intersect, any two non-adjacent angles, so any two non-adjacent angles formed by those lines are called what? Okay, so non-adjacent. So if we have, if I have something like this, I have two lines, okay, all right. Now we can see some adjacent lines. These two, this one here is adjacent with this one, okay. But if we were to look at two non-adjacent lines, that would be this one and this one, okay, or this one and this one. Okay, they are non-adjacent. They aren't right next to each other, okay, and they don't share a common side, okay. What they are, though, are, and you probably know this already because we actually use this term, they are vertical, or we could also refer to them as vertically opposite. Okay, it means opposite. They're opposite of each other. They're across from each other. Okay, so excuse me, and you can see those down here as well. These vertical angles down there. All right, and we have actually talked about them. We talked about the relation between vertical angles, and we know they are the same. Okay, so let's go ahead and read that last one here. And it says two lines are blank if they intersect in one point, and any of the angles formed by the intersection of the lines is 90 degrees. Okay, and that means any. Okay, any or all. Okay, in the sense of any or all. Okay, the two segments or rays are blank if the lines containing them are blank lines. And that term, I hope you know, is perpendicular. Okay, perpendicular. All right, so if two lines intersect and any of those angles, any of them, is 90 degrees. Okay, all right, right there, these are all 90 degrees. These are, because those are two perpendicular lines. Okay, and I'm not sure if perpendicular was anywhere down there. I don't think so. Okay. All right, so let's go ahead and see. It says here we also have some missing information. Complete the missing information in the table below. In the statement column, use the illustration to write an equation that demonstrates the angle relationship. Okay, use all forms of angle notation in your equations. Okay, I'm not sure. Let's just go ahead and do this together. Okay, so let's first deal with these abbreviations here. Okay, and this first one I'm not really very familiar with, but adjacent angles. It says there's like a little angle sign, and then an S, and then A, D, D. Okay, so that is the abbreviation for an adjacent angle. Now, vertical angles, okay, are vert. Okay, and the angle sign, and then a little S after it. Vertical angles. Okay, it's kind of messy there. I'm not sure how pertinent this is to anything, but anyway, statement here. Okay, so the statement here. So the measurements of adjacent angles add. Okay, in this case, very simply, if we look over here, we have A and we have B. We have A here, and then B here, angle A and B. They together equal angle C. Okay, so in terms of adjacent angles, if you add the two adjacent angles together, they equal the larger angle they make together, which makes a lot of sense. So in this case, A plus B equals C, and I guess we should put, actually we're going to put angle, let's probably put angle A plus angle B equals angle C in this case, okay? Not to be confused with these points here. All right. Okay, so vertical angles have equal measures, and that we know. In this case, we have angle A is equal to angle B. All right. So angle A equals angle B. All right, which is very important. And again, we're going to solve for unknown angles in this lesson. So this is all going to be very important to when you're writing equations. Okay, so now I did those two first because I split these up on different pages. So here are angles on a line, and we talked about these before. And angles on a line, abbreviation. Again, this just seems kind of silly to me, but the angle and S on a line. Maybe they're going to use these abbreviations in these problems coming up to help you out. I don't know. Okay, so for angles on a line, we can see if the vertex of a ray lies on a line, but the ray is not contained in that line, then the sum of the measurements of the two angles formed is 180. Okay, and here we can see here's a line right here. Coming off of that line is this ray. Okay, the ray is not contained in that line. It's not part of that line. Okay, what it does is actually just splits that line into two different angles. Okay, and you can see that's angle A and angle B, and very simple. Angle A plus angle B equals 180 degrees, and we've seen this before. It's kind of a little bit of a refresher. Angles at a point, and again we did this one as well. Angles at a point. Okay. So suppose three or more rays with the same vertex separate the plane into angles with disjointed interiors. Okay, then the sum of all of the measurements of the angles is 360. So you have a point, a common point right there, and then you have three rays coming off of that point. It doesn't need to be three only, just multiple rays. Okay, in this case we know that all of these together, this plus this plus this, is going to equal 360. So angle A in this case plus angle B plus angle C equal 180 degrees. Okay, angles at a point. Okay, in this case of with disjointed interiors. Okay, there really is no interior truly. Maybe this is interior to, well, no, they're not. But anyway, that's what that means. And angles on a line, I think you are familiar with already. Well, there are some recommended activities to do prior to having you look at this table here. But we're not going to do those because they work better in a class, and I'm really interested in kind of cutting to the chase here to come up with these two definitions. What we can do right here is I can just tell you here are these two terms. They may or may not be new to you, but in terms of angle relationships, we have something called complementary angles and then supplementary angles. And again, I am not exactly sure about and why this terminology was chosen for both of these types of angles. Not types of angles, but these relationships. Okay, because to complement something means to add to something. You know, supplement something also means to give something that's missing, kind of. You know, so again, I'm not sure exactly why somebody must have come up with this, and maybe somewhere in this module, though I doubt it, we'll find out why exactly these two terms were devised. Anywho, what I'm going to ask you to do right here is come up with a definition just by looking at these diagrams. If you could just go ahead and write a definition for complementary angles based on its diagram, the diagrams they give you there, okay? And then do the same for supplementary angles by looking at the diagrams they give you here. So go ahead and do that. Write your definition, come back, and I will, I'll write some definitions as well. Okay, so if we take a look at complementary angles first, you might have noticed that complementary angles can be adjacent to each other, as you see right here in this top example. You can see these two are adjacent angles. Okay, they are adjacent, and you can see they form this 30 degree and 60 degree form a 90 degree angle. Okay, a right angle there. Okay, equals 90. That might not be enough to come up with that definition, but if you look down here as well, these are also complementary angles, and they are as well a 30 degree angle and a 60 degree angle, though they are no longer adjacent, but they happen to just be side by side, excuse me, disconnected entirely, okay, sharing no interior line or interior ray, okay? But what they both do, and hopefully this became clear, was they both equaled 90 degrees. Yes, and that is the only thing that makes them complementary. So if the sum of the measurements of two angles is 90 degrees, then the angles are called complementary. Okay, each angle is called a complement of the other. Therefore, right here, this angle, we haven't named it, but it's 30 degrees, is a complement of that 60 degree angle. And even though they are disconnected, this is also a complement to that. Okay, so that's it. 90 degrees. You see complementary, you think 90 degrees. All right? Therefore, then, if you hadn't gotten that before, you probably have realized already that the supplementary angle, and these right here are angles on a line, which are not only angles on a line, but they're also adjacent, okay? And you can see what angles on a line are always going to be. They're always going to equal 180 degrees, okay? But these supplementary angles do not always need to be connected, okay, or sharing any side or ray or anything, as long as they equal 180 degrees. Therefore, our definition: if the sum of the measurements of two angles is 180 degrees, then the angles are called supplementary. Okay, there we go. And again, just as with the complementary angles, this 120 degrees is considered a supplement of that. The same down here. Okay, one is a supplement of another if they equal 180 degrees together. Okay, their sum is 180 degrees. And again, the reason we learn this, of course, right now is so we can solve problems later for unknown angles. Okay, well, let's move on to exercise 1 here. And again, if I see something I think that might not be familiar to you, or you may need a little help with, I'm going to go ahead and kind of stop and explain it. But if there's something I don't explain that you really are stuck on, just please don't hesitate to give me a call. So here in exercise 1, it says, in a complete sentence, describe the relevant angle relationships in the diagram. Okay, so let's do that first. Let's just talk about that in a complete sentence. All right, and the relevant angle relationship. So it should be really clear here when you see something like this, when you have this little angle mark right there. Okay, which I'll just take off because it's just, mine's pretty obnoxious. But this one right here, and then you have this x degrees right here. Okay, that written there. What that means is that that x degrees right there refers to this entire angle right here, okay? Though it looks like it just sits in this area, it doesn't. It refers to this entire part right there, okay? And here you can see there's been 22 degrees. There could have been something written like that, which may have been helpful, but they didn't. But just know that 22 degrees, of course, refers to that angle right there, okay? So I'm just going to do this with you right here. So in a complete sentence, if you want to just pause it and then come back and see if you've written the same thing as I have, that is fine as well. But in a sentence, I would just say the angles, let's say the angles x and, remember, x degrees and 22 degrees, okay, are supplementary, okay, and equal 180 degrees together, or equal, or sum to, or whatever. Okay, yeah. So I can say that in a sentence. I would just say that I can see that because I know that I know they're supplementary. First of all, because I know about angles on a line. Okay, I know that these are angles on a line. Here we go, boom, and then boom. Okay, there's two of them. So I have angles on a line, and I know angles on a line are going to equal to 180 degrees. And I know that 180 degrees, angles that sum to 180 degrees are called supplementary angles. Okay, so there we go. That's that part. All right, now they're asking us, beyond that, is to write an equation for the angle relationship shown in the figure and go ahead and solve for x. Now again, we need to draw on some of the knowledge from the past, okay, and hopefully you guys and gals out there will remember some of this. If you don't, let's just go ahead and do that. Let's do this one together. So we're going to go ahead and write an equation. Very simply, we could do x plus 22 equals 180, and we could just leave the degrees out of it for now. Drop all that, and then just put it in later. Okay. What do we do here? We're trying to, again, when we're solving for x, because that's what we're solving for, because that is our unknown. Okay, we are going to isolate it. And the way to isolate it, of course, is to get rid of anything else that sits by it, which is this number 22 is 22 here. So what do? We add its additive inverse, which is just like subtracting 22. Okay, and what we do on one side, of course, we need to do on another side, since we subtracted or added a negative, added its additive inverse. We have to do the same to the other side. Okay, so we get rid of all that. So now we have x equals 158. Now we can put our degrees there. So now we solve for it. There it is, 158 degrees. So we know that this right here is 158 degrees. And they ask you here, confirm your. So they ask you to confirm your answers by measuring the angle with a protractor. You can go ahead and do that if you have your protractor handy. If you don't, not a big deal. All right, so this example one here is another blast from the past. Boy, a long ago past. It seems so long that we talked about ratio. But anyway, so it tells you right here the measures of two supplementary angles are in the ratio of 2 to 3. Ratio of 2 to 3. So what does that actually mean? Okay, what does 2 to 3 mean? So if we look at this ratio, we could say for, and again, these are two angles, okay, two supplementary angles. So what we know already is, we know, and again, I'm just going to do this with you, and yeah, if you ever want to pause, just go ahead and pause. I'm not going to ask you to. We can just go ahead and fill in this side of the equation, because we know whatever we have, whatever these two angles are, they are going to equal 180 degrees. Okay. What does 2 to 3 mean? So it means for every 2 there of one, there is 3 of another. Okay? Every 2 of one, there's 3 of another. Right? So as you can see here, if we look at this tape diagram here, we know that we have 1, 2, and then we have 1, 2, 3. So altogether we have 5 pieces here. Okay, we have 5 pieces. 1, 2, 3, 4, 5, which all equal 180 degrees. Okay, so it's 5 pieces. But now one of these is going to be, one angle. Okay, and we'll just call the basic measure, because all of these here are the same. Each one of these blocks here represents the same amount. Okay, same amount here. So for each of those, the same amounts, we can put an X for each one of those, X and X, because these are two different angles. Okay, angle 1 and angle 2, we'll call them. Okay, all right. For this one, it's 2 of those boxes worth, and this one, it's 3 of those boxes worth. Okay, so we have 2X and 3X. Now, how do we go ahead and put them into the equation? Very simply, because we know when we come up with two supplementary angles, okay, and the way we get to 180 degrees is by adding. So we would add 2x plus 3x equals 180, okay? And again, working with ratios, right? Good way to work that out. Maybe do a tape diagram like I just did first to figure that out, okay? Because it's not so easy at first blush, okay? Looks a little bit more difficult than it truly is. But anyway, so if we do that, then all we do is we add our x's, okay, because it's the same as saying 5x equals 180, because we figured that out already, okay? We already knew that because we knew these 5 boxes here were all going to equal 180 already, okay? So the way to do that, of course, now in this case, we want to isolate that x, okay, this 5x. Now it's we can't, we have nothing to subtract away because we have no coefficient or anything like that, no just sitting number there. So if you do remember, hopefully you do. If you want to pause and do it yourself, go right ahead. But I'm going to go ahead. I need to isolate that x. I want it to be 1. So what do? Of course you remember. I am going to multiply it by its multiplicative inverse, okay, which is that right there, okay? And of course that's going to be x, because 1/5 times 5 over 1 is 1. I'm going to do the same over here. So I have 180 over 1 times 1 over 5. I could cancel, of course, and that is going to equal 36. So x equals 36 degrees, okay? So x equals 36 degrees, right? But I need to, my assignment here was to find the 2 angles. So I'm finding the measurement of the 2 angles, okay? So angle number 1 we called 2x. Therefore, 2 36s is going to be 72 degrees. So I have one at 72 degrees. I have another one that is 3x. And if I multiply that times that, what do I have? I have 108 degrees. Okay? All right, because that is 3x. 3 times 36 here. And the way I know this is correct is if I add these two. And if they equal 180, which they do, then I have checked my answer. Okay? All right, so that's how you do that example 1. Hopefully you'll run into something like that in your problem set, so you'll know how to do it. Okay. So here we go. Let's have you try this one here, exercise 2-4, by yourself, or not 2-4. The exercise is 2 to 4. Do exercise 2 by yourself. I said I wasn't going to ask you to pause, but I am going to now. Want to see what you can do here, again, using your definitions. Now, In a pair of complementary angles, and again, we just need to remember what that means. Go back and discover if you'd forgotten. The measurement of the larger angle is 3 times that of the smaller angle. Find the measurements of the two angles. So, use what you know or use what we've just done to help you do that, and come on back. Okay, so if we look at this again, complementary, okay, we know that we're going to have equal 90 degrees, all right, so we know that we're going to have two angles, okay, because complementary angles we're talking about two, the sum of two, so it's going to be something plus something, all right, equals 90 degrees, all right. So if we have a larger angle and we have a smaller angle, okay, now this larger angle is 3 times that of the smaller angle. And if you remember from way back when we had something like this, 3 times that of something, okay, this, the item that there was an of the smaller angle here is going to be our x, okay, whereas the larger angle, which is 3 times that other thing, so 3 times that x is going to be 3x, okay, so 3x plus x equals 90 degrees. Now this makes sense, of course, because you have x and then you have something that's 3x or 3 times that x, so that makes sense there. So if we just follow through with this, we have 4x equals 90, okay, and we go ahead and do that, and we again multiply by the multiplicative inverse, which is 1/4, and if we multiply 90 by 1/4, then we get 90 over 4, and we get 22.5 degrees. Okay, so x equals 22.5 degrees. So where does that leave us? That leaves us with the smaller angle being 22.5 degrees, but the larger angle we're going to need to, of course, multiply by 3, because it's 3 times as big, okay, and we end up with, what do we end up with, 67.5 degrees as our larger angle, and if we add those two together, we do indeed get 90 degrees, okay, so this plus this equals 90 degrees, therefore we have done it correctly, okay. Alright, so here's another one you might want to try for yourself. The measure of a supplement of an angle is 6 degrees more than twice the measure of the angle. Ooh, now we're getting tricky. Okay, they're really asking us to draw from the past. Okay, after we haven't done this in months and months and months. Okay, but here we are, and this is kind of the review, I think, that some of you had asked for, or were worried that you've been forgetting some things and wanted to have some review. Well, here you go. All right, be careful what you wish for. But anyway, this is good, I think, very good. Well, go ahead. I'm going to pause here, and I'd like you to give this a whirl, and then come on back, check in with me. Okay, so let's start solving this number 3. So, firstly, I see angle, angle. Okay, that angle is being compared to. It's become, the subject of comparison. Therefore, it will serve as our x. Okay, it'll serve as our x. Now, 6 degrees more, and then twice the measure. That's going to be the other angle. Okay. So therefore we have 2x plus 6. So we have two angles here. We have 2x plus 6, and then we have x. Okay, so those are separately our two angles right there. All right, angles 1, angle 2. Okay. Now we go ahead and solve, and we just combine our x's, combining like terms. Okay, so the 2x and the x are combined. 3x plus 6 equals 180. Of course, 180 comes from the fact that we are talking about supplements. Okay, and continue to solve. Okay, get rid of that 6, and then multiply by 1/3 both sides. And we come up with x equal to 58 degrees, and of course that is not the answer, all right, because the question is to find the two angles. So that's our pursuit. We have one, which is the angle of comparison, okay, which is 58 degrees, and then we need to apply the other math to its supplement, okay. We could just say it was 122. But it's always good to go ahead and use the calculations from the problem to solve it, because that would have been x times 2, because it was 2 times or twice the measure of the other angle. That was 116, and then you add another 6 degrees, because that's what it said. Yeah, right up here. Okay, it's 6 more than twice, and then you get 122. Okay. And those two equal 180 degrees, and therefore we were successful. Okay? Next one here, number 4, the measure of a complement of an angle is 32 degrees more than 3 times the angle. Find the two angles. If you'd like to, go ahead and pause right now and figure that out, and hope you're having fun, because it's kind of refreshing to be back doing these equations again, huh? Anyway, yeah, so if you want to, go ahead. If not, just follow along with me. I'll just set the problem up on this page, and then I'll click onto another page to complete it. But yeah, again, that word complement, of course, maybe some new vocabulary for some of you, maybe not. But of course, that is going to summon us to know that these two angles are going to equal 90 degrees. Therefore, we can set our problem up like that first. Again, we have angle being compared to, we're talking about 32 degrees more than an angle, 3 times that angle. Therefore, it is going to be x. Okay, it's going to be the angle of comparison. And our other angle, of course, is going to take into consideration, in this case, the fact that it is 32 degrees more than x, and it's also 3 times more than x. It's 32 degrees more than 3 times more. Okay? Therefore, it's going to be 3x plus 32, because it's 3 times and then add another 32. Okay, so let's go ahead and move on to a new page. Just rewrite our equation as it sits. There it is. Again, you know, first thing to do, add like terms. Therefore, 4x plus 32 equals 90. Take away that 32. Again, this is, boy, it's probably come back to you and just rushing in, huh? All the fun we had doing these equations. We're down to 4x equals 58, and we go ahead and multiply by 1/4, or the multiplicative inverse, and we get x equal to 14.5. And again, of course, our job is not done, but because we know that is the one angle, 14.5 degrees, but we need to go ahead and apply the other applications to figure out what the other angle is, and we know it's 3 times that, so 3 times 14.5 is 43.5, and it's not only 3 times, but it's 32 more than 3 times. Therefore, we add 32, we get 75.5, and if we add 75.5 to 14.5, we get 90 degrees, and that's exactly what we were shooting for, because these two were complementary angles. Okay? Now, here's another one. Example 2. So 2 lines meet at a common vertex of 2 rays. Okay? Common vertex of 2 rays. Now, if we look at this here, before I go on to the rest, just to identify what we're looking at, here are our two lines. Here's our one line and our another line, okay? Now those two lines meet at a common vertex of two rays. Now here are the rays right here. Okay, that's a ray. It should have actually everything should have arrows at the end of it. But and there's the vertex of the two rays. There's right there in the middle. That's where of course they meet. Okay, but these two lines meet at the common vertex of these two rays. So you can see what's happening here. There are the rays, and there the red are the lines, the black are the rays. Okay. Therefore, if you would, go ahead and try this on your own first, set up and solve an appropriate equation for x and for y. Okay, so go ahead and see what you can do with that using what we know. Again, we're looking at y is going to be right here. Okay, it's that angle, and x is going to be right there. Okay. And I think you might get an idea of what the relationship they have. But go ahead and give it a try. Well, I hope I didn't confuse you on this one by all that mess that I had drawn before, because I did notice something, and maybe you did notice it already. If you saw the square box right here, okay, in there, it looks like this. These two rays here together form a 90-degree angle. And that's what that box is. Okay, so that box that's a 90-degree angle. Therefore, what we should know is that this 16-degree angle here and y are complements. Okay, they are complements because of this box right here. And if you didn't see that, I'm sorry, because I actually missed it as well. So, so we know that they are complementary angles. Therefore, we could write a very simple equation, which would be 16 plus y equals 90, okay, because this plus this has to equal 90 because they are complements, all right? And that would be, then we had to just subtract away that 16, y equals 74 degrees, okay? So now we know that y equals 74 degrees. We can actually just go ahead and write that in here, okay, because that's going to help us. And again, you might have started with x, you know, so and that's fine. But I went ahead and started with y. It looked a little bit more logical to me because what I know now, if I know that y equals 74, okay, I can also see that it looks like to me that angle x, which actually does, like I had said before, go all the way around like that, okay. As you can see, that little circular little angle symbol right there, little angle, little angle arc, whatever, okay. So therefore, if you notice something, that y and x sit on a line. Therefore, they are angles on a line, which we know to be supplementary. Okay, so supplementary. Now we started out with some complementary angles over here. Okay, the 16 and then the y. Okay, and we came up with that. And now we can see that these two, the x and the y, are supplementary. Therefore, we can go 74 plus the x equals 180. Okay, because our supplementary angles equal up to 180. And then if we do that, subtract this away, we end up with x equals, and subtract 74 over here, equals 106 degrees. Okay, so we therefore have 106 degrees for x. 106 degrees. And there we go. So I hope you had fun getting back into this, back into these equations. I sure did. At first I thought I was going to dread it. The only thing I dread is that these lessons are probably going to end up being like 45 minutes or over from here on in, which this one is. Anyway, again, I hope you liked it. Some points here. We learned about supplementary angles are two angles whose sums are 180. Complementary angles are two angles whose sum is a measurement of 90. Okay, and I can only think to remember this. I mean, C is close. C comes before S in the alphabet. Okay, and 90 degrees comes before 180 in numbers. I don't know. I'm trying to remember because sometimes people get these mixed up. Supplementary is 180, and then complementary 90 degrees. All right, so C actually comes before S in the alphabet. Therefore, C is the smaller angle. Whatever. Maybe you can remember that. Maybe not. Anyway, once an angle relationship is identified, the relationship can be modeled with an equation that will find an unknown value. All right, the unknown value may be used to find the measure of unknown angles. And again, I am really happy to be back to equations. I hope you are as well. Good luck with your problem set, and see you for some more fun in lesson 2.